So what we're going to do, when something grows or decreases exponentially, now we hope it's something like money. Most of the time though, it's something more like in science with like bacteria or an element, or maybe our car going down in value, or something else that we own, doing with it like that. So when we're going to have growth, we're going to talk about the good stuff first. It's going to be modeled by this thing where it looks kind of crazy at first. Y equals a times b to the x. What's all this mean? A is just how much we start with. Now again, that can be money, bacteria, how much something's worth, people, it can be anything. The B part though is the part that kind of becomes important. Our B is our base. What are we starting with? And it's called a growth factor. And what I did over here is I kind of put, we're going to add something to it normally. So it's 1 plus, and they'll tell us how quickly it's growing or decaying. Well, if it's growth, it's going to be plus. So we're always going to use this 1 plus number, and then X will tell us how long we're going to look. Is it a year? Is it 5 minutes? Is it 10 years? We don't know. So we're going to kind of discover it first, then we'll start using the formula to see how this works. So, for instance, all right, John got himself 3 fish. Okay. Salesperson at the store said they would double in number every month. Ooh, they're busy little buggers. Complete the chart below to show how many fish John has each month and then graph it. Okay, here's our first thing. If we were putting this into the formula, John's starting with 3 fish. That would be my A value. That would be my starting amount. So, in month 0, when I first purchase them, we have 3 fish. If they're going to double, if you multiply something by 2, it's the same as doubling it. So, what we're going to do here is we're just going to go ahead for now and build this chart and keep multiplying by 2. Now, we haven't made our labels here yet, where we probably, and I'm going to go ahead and I'm going to skip every other line here so we can have a little better of a look at what's going on here. So down here on the bottom part, this is where we're going to deal with our months. And then up the side is going to be where we have our number of fish. Now, I probably don't want to count by ones going up the side because I'm probably going to run out of room. Any ideas maybe on how much I should count each line for? What's that? 3s maybe? Oh, I think we still might run out of room. 5s, maybe even 10, something like that. Let's see about 5s here. Well, now let's see here, because we may find out. And you're like, wait a minute, I thought you said you were going to go by 5s. I am, but notice I'm just spreading it out. So, I'm going every other line with my 5s, or to make a little more room, I'll just do it with the 10s. So when I'm doing this, at 0, I'm at 3. So I'd be a little below this first line, since each line's worth 5. And for the ones that I've been given so far, I'm going to go ahead and I'm going to get those plotted in. Now, it may look like sort of like it's heading towards a straight line right now, but that's going to change here pretty quickly. Because when I get to the 4th month, I notice that I multiplied by 1, 2, then 2, then 3. So this time I'm going to take that and I'm going to multiply by 1 more. So I can either break out the calculator for this, or I could just multiply that last one by 2, I guess. But make sure I get the right number of 2's here. Yep. Okay. So in the 4th month, I'm up to 48 fish. I hope he's got a big tank for this, or this could become tricky. But you notice how quickly now my dots are starting to go up. When I get to number 5, now see, I've learned my lesson. I don't have to write all this. It's just going to be whatever my last answer was, times 2 more. Yowzers. We were talking before about how 5s maybe, well, shoot, I only go up to like 70 here, and my number's at 96. So I guess we're going to go a little off here, like up here somewhere. And I notice, if I go to connect the dots, that once I start getting further down, it's almost like it's heading straight up. It gets really steep. And that's the idea of exponential growth, that it may start slow, but then it really starts to go fast on the way up. So you're like, wait a minute, number of months n? That's not a number, it's a letter. But it lets us talk about it in general. So what we're going to do here is, my equation would be y equals, I start with 3, so that's going to be my a value. And then the amount that it goes up each time, I'm multiplying by 2, would be my b value. And by doing it in general like this, it lets me find out if I wanted to know 50 months from now, how many fish am I going to have? I don't think I want to know. It'd be a lot. Even after a year, it might be crazy. But if I wanted to look ahead then and look at something and say, okay, I want to know in 12 months, in 1 year, how many I'm going to have, I could just do 3 times 2 to the 12th power, since it'd be 12 months. And I'd find out he'd have like 12,000 fish. He'd better have like an entire house available for these fish, unless they're really, really, really tiny. But that's what we're kind of looking for here. Now, you're not going to have to get quite this creative when we're doing ours, but I wanted you to see one from the start to see how these work. What we're going to do is we're going to be given a problem that's already set, and then we're just going to type the equation in the calculator and let the calculator do all the work. So here's how this works. We got a new automobile. It currently costs $15,000. The cost increases 5% each year. Determine what the cost of a new car would be after each of the following years. So what I'm going to do is, what I'm going to type in is my A value, my starting cost, would be $15,000. That's what I'm starting with. Then, since it increases in value, my base number is going to be 1 plus the 5% as a percentage. So that's where this 0.05 is coming from. So when I want to figure this out, what I'm going to do is I'm going to let the calculator do all my work. But I need to know how to punch it in, of course. So here's how this is going to work. We're going to hit y equals. We're going to use the graphing function, but we're not necessarily going to use the graph itself. And I'm going to type this in. So I'm going to type in my starting value, my 15,000. And then in this case, since it's increasing, it'll be 1 plus my percentage. So 1 plus 0.05. And then I need it to the x power. You're like, well, why the x power? Because the calculator then can plug in the numbers for me. So I use my little caret button for my exponent. If you have your own calculator, I'm sure you have an exponent button somewhere. So it's going to look like this on these. Now, if I went to hit the graph, it's not going to do me much good, because you're going to notice, well, there's nothing showing up hardy. Why is this? Because these numbers are outside my normal range. So here's what we're going to do. We're going to hit second graph. That's going to get me a table. And I made note of that right here. I'm always going to use second and graph to get the table. And I look, I'm like, oh, I bought it, it was $15,000. And what the table tells me is what the value will be each year. Bless you. So after year 1, it'd be worth $15,750. Oh, after 1 year, $15,750. And I can start seeing as the years go by, okay, my x value is the number of years, and I just copy the value that's next to it. So you know what to type into the calculator to get the information that you need out. Okay, year 5, I just go down to when x is 5. This car is getting a little pricey. So I can figure out if into the future I'm going to need another vehicle, how much money I'm going to need. And that's kind of an important thing in understanding how this is going to work. So my job on most of these problems when we're doing growth and decay is going to be taking the equation, creating it, and then punching it into the calculator. So here, okay, we always start with y equals. So we have a city here. So how many people am I starting with? 450,000. And then it's always going to be 1. It's increasing, which means it's plus. Now here's the interesting part though. How do you write 2.5% in a decimal form? I know there's a decimal point there already. Would it be 0.25? No, that'd be 25%. So what's it going to be? Yeah, 0.025. And then I'm always going to use x as my exponent. Once I get this part done, I can always go to my calculator, go back to y equals, because I have to be in the y equals to let the calculator do all this stuff for me at once. Could I, if I didn't have a graphing calculator, could I do this? I sure could. And I'll even show you here for a minute how I could do this. I could, if I didn't have a graphing calculator, type in 450,000, 1 plus 0.025, and then whatever year I'm looking for, I could just type that in as my exponent. So like I'd do it to the first power here. And I'd hit enter. Oops, not 250. Now the thing that can get a little tedious about this, and why I like the y equals better, is every time now I have to go back and I'd have to type in the whole expression, but the only thing I'm going to be changing is my exponent. Now here's the one thing I have to watch out for. These are people. I can't have 0.78 of a person. So you round to the nearest whole person in this case, since we're talking about people in a population. But again, if I don't want to have to type it in every single time, and I have access to one of the calculators in class, and you know how we work, we always are working where we get you time to work in class. It just depends on if we use it or not. I always can go to y equals and just use x as my exponent like we did for the first example we did, and use second graph, and you'll notice my 1 year, yep, got the same thing. My 3 year, yep, got the same thing. But now instead of having to type both of those other ones in, I can just look at my chart and scroll down to the year I want and figure out how big the population of the city is going to be. Well, why would you want to know that? Lets you know how many jobs you're going to need, how many stores you're going to need, how much tax money you're getting. So people would actually use this to figure out how much money it's going to take to run their city. Just something to consider. But again, whether you type it in with the number each time and just plug that in for your x, or you use the y equals, they both are going to work pretty well for us that way. But then there is decay, because everything in the world does not go up in value all the time. But you're like, the formula is the same. That's true. There's only one thing that's going to be different about decay rather than growth, and that's when we're in the parentheses, we're going to use minus instead of plus. If it's going down in value, it's decaying. So just like we had with our fish before, except we're going to do it with flowers now. So we're starting with 128 flowers. That's my starting value. That's my A. So Jane has 128 flowers, but she forgets to water them, and half the flowers die each month. Complete the chart to show how many flowers Jane has each month, and then graph it. So here, since we're cutting it in half, you can either multiply by half, or you can just keep dividing it by 2 every month. So like when I got here, I don't have to multiply it that way. I can just take my prior month and divide by 2, because 64 divided by 2 is 34. 32, oh my gosh. So for each month after, I would keep taking however many flowers I had the previous and just keep dividing it by 2, because they're decaying. Literally, they're decaying. And they're just going to keep dying off half every month until, well, basically they're all gone. So like we did before, we want to graph this, but we actually want it to all fit on our graph. So our months, again, it's okay if we do those by ones, because I've only got 5 here. But this time, I need to go from 128 down to 4? Eee. How many should I make each line worth so I can fit all this on my graph? I basically need to be able to get from nothing up to 128 along here. What might be a good idea to make each line worth? Is 1 going to work?
8, 6.
Oh, I'm hearing 8. I'm hearing 6. 12. We're just all over the place. Let's see how many lines we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. We got 16 lines. So what you could do, ooh, I like the way you're thinking about this. Oh. But I think I might have known what we might have been thinking here. Because you're like, okay, I need to get up to 128. There's 16 lines. And it ends up being 8. So hey, it's going to fit perfect. So okay, I'm for this. So I'm going to count by 8s. And if I'm not sure, I could always use the calculator to help me. I'm getting there. I'm slightly above because my 0 line isn't going to help me with this, but still, we're pretty good. So at 0, we're up at 128. And then at 1, we're all the way down to 64 already. This one's going down in a hurry. 32, 16, 8, 4's in the middle. So this one, and notice what the graph looks like. Now I can't go below the axis because I'm not going to have negative flowers. That's not possible. But it goes down from left to right when it's going to be decay, and it goes up when it's growth. So I can kind of visually see this. But when I'm making my expression, this time I'd start with 128, but then my decreasing part's going to be the 1/2 each time. And that's how I'd figure it out. I could plug any number I wanted to in for x and figure out how many flowers there'd be left at this point. But we're already down to 4, so there's not going to be too many left after too many months here. But that's where it's coming from. But again, the key is just looking for the words. Suppose an acreage of forest is decreasing by 2% each year because of development. So I'm starting, that's a lot of forest. I'm starting with 4,500,000 acres. But since it's decreasing, instead of doing plus and the 0.02, I'm going to do minus. And since I am always a proponent of saving time, I'm going to go back to y equals and clear out whatever's there. I'm going to type this in. Make sure I get my zeros right. 5 of them, yep. Type it in with a minus because it's decreasing. And then I just use my little exponent button, my little caret, my little up arrow here, and I just use x. Because if I plug a number in there, my chart's going to come back with every number the same. And that's how you'll always know if you're doing things all right. Because like for instance, let's say you did this and you're like, oh, I'm just going to punch in 3. And I go to hit second graph and it's like every single number's the same. You're like, what the freak? What's going on? Now the other thing you may notice, let me go back to y equals and get this to x. Because I want to run you into something else that may bother you. You're like, what are all these e's? Like 4.24e6, what does that mean? Basically that means it's 4.24 times 10 to the 6th power. Now, I may not be able to recognize right away what that means. So for right now, I'm just going to write down what I see here. I'm going to put it down here so I can see what this means in a second. So 4.24 e to the 6th. We're not going to leave it this way, but we're going to write it down till we figure out what this means. So 4.07 e to the 6th, 10 years, 3.68 e to the 6th, 20 years. That's a long time. 3 e to the 6th. So this e to the 6th thing, okay, let's try and figure this out. I'm going to get out of the y equals mode for a minute here. And I'm going to type this in with my 3 out here, and I'm going to see if it does e to me out here. All right, so 1 minus 0.02. And I'm punching 3. Okay, well, I didn't get E this time. I actually got a number I can use. So what's the difference? What's going on? What this is telling me when I get E is that I need to move my decimal 6 places to the right. So if I took 4.24 and I moved it 1, 2, 3, 4, 5, 6 places and put commas in, those are pretty similar. I know there's about 5,000, no, actually a little more than that. No, about 5,000 difference. So if some of you, the E freaks you out, just type them in individually like we did here. Because what I can do then, and I'm going to do that for another one here. So let's see, 5's the next one. So I could type in just with the number 5 for my exponent and get an answer. Or again, that E value just means I'm going 1, 2, 3, 4, 5, 6 places. And again, my answers are real close to being the same. So if I understand E, great. If the whole E thing, because I'm not leaving E as part of my answer. People don't talk that way. You wouldn't go up to somebody and say, hi, there's 4.07 times 10 to the 6th people. No, probably not. So if in doubt, we'll just go ahead and do it individually this way. Now, I'm not always going to get numbers that are going to be this crazy. So more times than not, it's not going to be that big of a deal to plug it into the E. But if it ever is, if I don't want to plug it into the Y and get E, I can just do them individually. It didn't take me that much longer. It's not really that big of a deal. And I promise this next one is not going to be that way. We're going to be able to just plug it in and do the Y equals. So our last one, starting with 10,500 bucks. That's a good start. But we're decreasing the amount we have by 15% each year. Yow. So I'm going to minus by the 0.15. And again, I could type this into the calculator and just replace x with the numbers, but I want to see if this one's going to be a little nicer this time where I don't have E that I'm worrying about. Second graph. Got to back up here. All right. This time, numbers are much better to work with. Year 1, my investment's already down to $8,925. We are in trouble here. 7,586. We'll just round to the nearest dollar. Look at how quickly my money is going bye-bye. Whew. And again, or I could just plug in 1 for the x, 2 for the x, 4 for the x, 10 for the x, and get my values that way. Either one would absolutely work. The only other thing that we haven't talked about on this sheet as far as growth and decay go that I'll need to talk to you about is actually on the worksheet. So I'm going to do a couple of things with you on the worksheet too, just to make sure we're doing things all right. So let me move this, swing the worksheet in here. And this one, again, for those of you that label, and that's probably a good idea. We're just starting up here on homework check number 5, since we just had one yesterday. So this is assignment 1. It says, please read all the instructions carefully and box your answers. Okay. Determine the multiplier. So basically what we're doing is we're looking where it says growth or decay and figuring out if I'm doing 1 plus a percent or 1 minus. So I did number 1 for you already. Growth means it's plus. 5% as a decimal is 0.05. And if you're not sure, if that's not one of your strengths, turning a percentage into its decimal, there's a very simple way to do that. Take the percent and just divide it by 100 on your calculator, and that'll give you the decimal value. So like if I was doing decay, I know it's going to be 1 minus, because, well, decay subtracts, and then I could just do 12 divided by 100, input the 0.12, and I'm done. Okay, that's all I want you to do here, is determine what your multiplier is going to be. And if I give you something funky, like tripling or quadrupling, you're like, ooh, tripling, what? Okay, quadrupling would be a 400% growth, because quadruple means times 4. Tripling would be a 300% growth. So just something, I'm throwing some words in there that are a little bit different that you may not be used to seeing. So that's what they're going to be. But I'm just writing this 1 plus or minus, and I'm done. And then finally it says, state whether the growth formula is model growth or decay. So for instance here, 3 to the x, if my value in the parentheses is bigger than 1, it's going to be growth. If it's less than 1, it's going to be decay. Now, if some of you are more visual, I can actually type this into the calculator and see it. If I type in 3 to the x and hit graph, notice it goes up to the right. Whenever one of our graphs goes up to the right, it's growth. If it goes down to the right, like maybe if I plugged in the next one, 0.25 to the x, notice it goes down to the right. So you can do it either with knowing the little formula up here or by visually typing it in the calculator and seeing what it looks like. But here's the weird thing. Uh-oh.
Here's the interruption.
So I look at this and I say, well, wait a minute. 1.01 is greater than 1, so this should be growth. But I'm going to type it in just to make sure. So I'm like 1.01 to the negative, oops, I want to make sure I put this in parentheses here, to the negative 2x. And I hit graph and I'm like, whoa, that was not what was supposed to happen. What did I do? That turned out kind of strange. Well, let's hit the graph again here. I notice it's kind of going down this way. So I did make one more note on here. A negative exponent creates the opposite. So this would normally be growth, but I see a negative exponent. So it actually ends up causing the opposite of what I'm doing. And we'll look at one more like that. Hopefully this next one will show up a little bit better for us. If it's negative exponent, it's the opposite of what I would think it is based on this. It's not always going to be negative. Because like if I look at this one, if I was to just look at the value of the number in here, I would think it's decay because that's less than 1. But if I look at the graph, it goes up to the right. It's actually growth. So if I see a negative exponent, I have to think the opposite of what the base tells me. And that's all I'm going to do on these. Okay, so I can either punch them in the calculator, or I can use the hints that we have up here to help me. And then the back of this worksheet's just like the ones we did on the review. And we're going to do some more talking about these type of problems tomorrow, like how to figure out growth and decay just by looking at the expression.